Hello, we are Team HARP, a group of master students from Carnegie Mellon University's Robotics Institute. Our Amazon Picking Challenge robot consists of a UR5 arm, a Kinect depth sensor, and a custom suction end effector. The robot determines the location of the shelf and order bin via an iterative closest point algorithm. Since the UR5 is statically mounted to the floor, this algorithm only needs to run once at startup. After the shelf location has been identified, the state controller can plan out a series of actions based on shelf content. In this video, the UR5 is shown accessing the shelf workspace. The arm is being controlled via the Move It planning interface. We are working to integrate a planner developed in Carnegie Mellon's search-based planning lab. This planner discretizes the search space and collision models to generate faster and deterministic arm paths. The vision system consists of a Kinect depth sensor mounted to the end effector of the UR5. During the object recognition step, the arm is positioned outside the shelf bin. Several images are captured and merged from different perspectives. Segmentation algorithms cluster the shelf contents into individual items. Then, a score between each ground truth model and shelf cluster pair is calculated based on the point cloud matching, camera perspective, and shelf geometry. The vision system outputs a pose of the item of interest. We are currently working on an advanced perception algorithm to handle more cluttered shelves and partial occlusions. Our end effector is designed around a high-flow, low-pressure vacuum system. The tool, shown here, is low profile and extends out approximately 12 inches from the UR5 in order to reach items deep in the shelf. Redundant pressure sensors inside the vacuum hose identify when an item has been grasped. While we wait for our UR5 to arrive next week, we are performing system-level testing using RViz simulation, combined with live Kinect data and feedback from our suction end effector. Here, you can see the entire picking task state machine in action. The arm is pre-positioned outside the shelf, and RGBD data is captured. After identification, the end effector reaches into the shelf and grabs the item. The item is then transported from the shelf into the stowage bin. Currently, we are strategizing for the stowage task. During this task, the Kinect will capture a top-down view of the bin. The vision system discretizes the scene and determines an ideal grasping surface. The item will be lifted from the bin and then identified in isolation. After identification, the item will be placed back onto the shelf. Which bin the item is placed in depends on the item size, as well as the configuration of the shelf. Thanks for watching. Team HARP hopes to see you at RoboCup.